Alternating current describes the flow of charge that changes direction periodically, causing the voltage and current levels to reverse. When an AC voltage is produced, the voltage switches polarity over time. When graphed over time, the wave traced by the voltage of alternating polarity takes the shape of a sine wave. AC can come in a number of forms as long as the voltage and current are alternating. The most common type of AC is the sine wave, which can be seen in most homes and offices. An AC function waveform generally follows that of a mathematical sinusoid, as defined by AT equals A max times sine 2 pi f of t. The shape obtained by plotting the instantaneous values of voltage or current against time is called an AC waveform. This is constantly changing its polarity every half cycle, alternating between a positive max value and a negative max value, respectively with regards to time. The AC waveform has characteristics such as the period, the frequency, and the amplitude. Sine waveform is defined as Vm equals 169.8 sine 377t volts. Calculate the RMS voltage of the waveform, its frequency, and the instantaneous value of the voltage Vi after a time of 6 milliseconds. To compare this to our given expression, we can see automatically that the peak voltage is 169.8 volts. To find the RMS, we take 0.7 and multiply it by the maximum peak value, which gives us 120 volts. The angular velocity is 377 rads, which means we can find the frequency by dividing that by 2 pi, giving us 60 Hz. The instantaneous voltage Vi after a time of 6 milliseconds can be found using the steps below. Note that the angular velocity at time t equals 6 milliseconds is given in radians, so we have to convert this into an equivalent angle in degrees and use this value to calculate the instantaneous voltage value. We can do this by dividing 180 by pi and multiplying it by the radians, giving us 129.6 degrees. We can see that the AC describes the flow of charge that changes direction periodically, whilst the voltage and current levels also reverse. Hopefully this helps you understand the basics behind the AC sine wave.